Making predictions from data. Our standards today are I can calculate experimental probabilities from experiments, and I can use experimental probabilities to make predictions when actual probabilities are unknown. So why learn this? I want you to draw your line down, and I want you to write this statement. Probabilities can help you make a prediction about the outcome of an event. So here's an example. 1 out of every 23 pairs of genes is defective. About how many defective genes will be in a batch? So that's what we want to figure out. Well, if you know 1 out of every 23, then you can figure out there's about 13 pairs that are defective. Why should we learn this? Well, this will not always be true, but at least the company can then budget for these defective pairs and figure out how much money they'll make and what they should charge for them. So let's write making predictions. Here's what I want you to write. Probability times the number of trials you want to figure out, and that will get you a predicted amount. This is what it looks like in your textbook. Probability of an event times the number of trials you want to find out will equal the number of predicted successes. So let's look. If a toy company makes robots, they inspect 200 of them at random. The sample has 5 that do not work. So that's a 5 out of 200. So for every 200 robots, 5 will not work. Now I want to find out how many that would be if I have 15,000 robots I made in my factory. So the easiest thing to do is to turn this to a decimal, which is 0.025, and then you just times that by your 15,000. When you do that, you will get 375 robots that will not work out of the 15,000. So again, here's the same thing. Let's do it again. For every family with 2 children, suppose there is a 25% chance that both children are boys. Well, there's our probability. It's just written as a percent this time instead of as a fraction. We want to times that by the number of trials. Well, this is the number of 72 families we want to do, and we want to see what we get. Again, turn your percent to a fraction or to a decimal. So if I cross it off and I back it up, I'll get 0.25 times 72. So if I take that on my calculator, I get 18. So out of 72 families I talked to, 18 of them would have 2 boys. Last one, I want you to stop the video now and I want you to try it and then turn the video back on to see how you did. At an arcade, Juanita plays a game 20 times. She has 30% chance of winning. How many times can she expect to win? So we take our 30% times the 20, because that's the number of times she did something. So we turn this to a decimal by crossing it off and backing it up, which would give me a 0.3 times my 20 tries she did that. Which would then give you how many times she'd expect to win? It'd be 6 times. So 6 times out of 20 she would expect to win. You'll now complete your worksheet.